Walk through quickly. Brad said we're going to apply all of these theorems, and you can see the rules there. You can see how they're going to apply. We're going to do some of these. We're going to prove every single one of them, but at some stage later on. We've got lots of time to prove them. We'll probably spend 3 lessons working on circle theorems. Okay, so they're the rules there, and we're going to look how can I use those rules in the problem that I'm given. So we're just going to refer to this table. There's our notation that we're going to be using. We've copied that down. We're just going to solve all these problems. This is our first one here. Okay? And so we're going to look for some of these images here and we go, which one can be helpful to us? And it's quite similar to the first one. It's important we're listening here, Noah. It's quite similar to the first one because it's sort of a semicircle. Okay, you can think of that as a semicircle. This is the diameter. It's cutting across the center of the circle. And so therefore we can use this first piece of information that if we have the diameter, then this angle, no matter where that point is going to be, this angle here is always going to be 90 degrees. Okay? So what we're going to say is we're going to say angle CAB equals 90. And that's because, what's our notation? Angle in semicircle. All right, so it doesn't matter where point A is located around that curve, it's always going to be 90 degrees. Now, just very quickly, some of these words aren't going to be familiar to us. Tangent, chord, segment. We're going to learn those as we're going. So I'm not going to get into them right now. You can find, I'll just advertise it. You can find a list of properties of a circle on the back there. Okay, that just describes what they are in reference to the diagram of a circle, and they're in this booklet too, in there. Okay, so let's proceed. So we've established this angle is 90 degrees, and that means x is going to be 180. Take away 90, take away 33. So we'll have x is 57 degrees. And a justification, angle sum triangle. That all the angles, this is a triangle because we have 3 straight lines, and all angles inside it add to 180 degrees. So therefore x is 57. All right, we know this angle is 90 because of our first circle theorem, angle in a semicircle. We're told the other angle, and so therefore, because it's a triangle, we've got 57. Excellent. Okay. Our next theorem here, we have what's called angles subtended by the same arc. So when we have, it sounds quite complex, and it is. To describe it in words, it's very complex, but it's easy to understand visually. In this diagram here, if we have 4 points, okay, on the outside of a circle with straight lines going across, this angle is going to equal this angle. Okay, they're in the same segment. And this angle is going to equal this angle. We've got 27. Okay, and we can use that information. So let's just do this statement. Angle EBA is 27 because of angle sub. Angles subtended by the same arc are equal. Okay, this is 27, this is 27, this is x, this is x. All right, and then we'll apply again. We've got a straight triangle there. Triangle AEB. So therefore, angle X is 180. Take 141 and then take 27. So we'll have 39, take 27, we'll have 12. Angle sum triangle. All right, now, in order to apply this rule, the points must be on the outside of the circle. Okay? So if you had a diagram like this, the rule does not apply. Okay? This point needs to be on the outside of the circle somewhere. Excellent. Let's proceed. Example C here. This is a simple application of the 5th rule there, angle at the center. So if we have this sort of shape, all right, so 2 lines going out, whenever we say O, that means the point of origin on a Cartesian plane. It means the center of a circle. So this is the center of our circle, and this angle is always going to be twice this angle when we have that sort of shape. So we can just say straight away x is 64 because of angle at center. Okay, last one here. We've got an equilateral triangle inside a circle, and we're trying to find angle x. So firstly, all of these angles are going to be 60 degrees, aren't they? Because it's an equilateral triangle, so we've got 60, 60, 60. So let's make that statement. Angle, what is that? ADC equals angle DCA equals angle CAD equals 60 degrees. And in brackets, we'll just put equilateral triangle. That's our justification. That's how we know those angles are 60 degrees. And then we're just applying our last rule, the angle between a tangent and a chord. Okay? It says if we have a triangle inside a circle, and this here is a tangent, that this angle is going to be equal to this angle. So therefore, x is 60 because of angle between a tangent and chord. Excellent. So what I'd like us to do is have a go at 9.1 and just keep those circle theorems in front of you and just get in the habit of applying them. And it will get more complex quite quickly. Let's get into it.